Hello everyone, welcome to this session of Physics Revolution, and today I am going to take spherical mirrors. Spherical mirrors, which is a grade 10 CBSE physics topic. And here you are going to know the spherical mirror for the first time. We are going to see why spherical mirror is called spherical and what are the properties of a spherical mirror, why are they so special, and I will also tell you what are the different positions and different components related to spherical mirror. So without wasting time, let us get into this. So let me show my screen share to you. What I'm going to tell you today is why a spherical mirror is known as a spherical mirror. Okay, we all know that there are two types of spherical mirror, convex and concave, and you must have studied that there are two types of spherical mirror, convex mirror and concave mirror. Now let me take you to something. Let me consider that I have a spherical mirror. When I say spherical mirror, it is completely sphere, which would be something like this. So let me show it to you what it looks like. So here I have a sphere. You can see I have a sphere in here, or else I'll take this one. Yes. Okay, I have a sphere. Let me make it two. Sphere number one, copy, I will paste it. Sphere number two. Okay, now look here in the first sphere. Okay, this first sphere has a radius r. So every sphere should have a radius r, isn't it? I have a radius r for the sphere. Okay, I'm keeping it very simple for you to understand. I have a sphere which is a mirror. Now you might be asking, what type of mirror is this? But I'll explain to you. Okay, it is a sphere, it has a radius r, and for this particular mirror, the inner side is shiny. Inner side is shiny and the outer side is rough. Okay, isn't it? Now actually, if you see like this, I am able to imagine, you need to imagine this. I have a mirror which is kind of a complete sphere, but in this sphere the outer side is rough, non-reflective, but the inner side is shiny and reflective. Now what I'm going to do here, and of course you should know that it has a radius r. It has a radius r. Now what I'm going to do here is I'm going to take this, maybe a glass cutter, I guess. I'm going to take a glass cutter and I'm going to cut it. Maybe from here, I guess. I'll cut it like this. Okay, I cut it like this, then I remove this portion. If you see, I remove this portion and I bring it here. What am I having? Look here, I cut that portion out and I removed it out. Now what you're seeing here right now is a concave mirror. What you're seeing here is a concave mirror, a mirror in which the inner side is reflecting. Okay, the inner side is reflecting. Concave mirror in which the inner side is reflecting. Same way, I have another spherical mirror, a sphere, and it also has a radius. Okay, every sphere has a radius, there is no doubt about that. Every sphere has got a radius. So I have the radius here, isn't it? I have a radius, and in this case our outer side is shiny, the outer side is reflecting, and the inner side is rough. Outer side is reflecting and the inner side is rough. That is the case in this. So I would make the inner side as rough. Of course it has a radius r. Okay, it has a radius r, So you see these lines represent rough surface of a mirror. I always say my students, whenever I draw a mirror, it has two sides. One is a shiny side and the other side is a rough one. If you remember, if I have taught you this particular thing, you might remember that I show one side shiny and other side rough, and the rough side I show by these kind of lines. Now what I'm going to do here, I'm going to cut some portion out just like what I did there. I'm going to cut this portion out. Let me take a straight line and I'm going to cut this particular portion out. Yes, I have cut it out. Now let me actually cut it out in the image. And yeah, it looks something like this. I have, and yes, look here. Now this type of mirror that I'm seeing is known as convex mirror. It's known as convex mirror. The outer side is reflecting. So I have a concave mirror, the inner side is reflecting. I have a convex mirror for which the outer side is reflecting. Now by this you get to know why they are called spherical mirror. This is the reason why they are known as spherical mirror. See students, there are two types of mirror. One is a plane mirror. Plane mirror is that you see in your house, in your cupboard or in your makeup room or whatever. That is what you call as plane mirror, and you exactly see the image that the object and image are alike there. But when the mirrors become spherical, there are some changes that starts to occur. Yes, there are some changes that starts to occur, and I will talk about those changes also, what is going to happen. Now they are called spherical mirrors because they are derived from an actual sphere and has a radius also. And has a radius. Okay. Again, I am telling you, this concave and convex mirror are derived from a spherical mirror. It's a part of a spherical mirror. That's why they are known as spherical mirror. And since they are a part of a spherical mirror, they have a radius. Every spherical mirror have a radius. And why do they have radius? Because they are part of a sphere. Simple. They are a part of a sphere, they will have a radius. And that is how they have a radius like this. Okay. The line that you extend here is nothing but their radius only. Okay. So maybe like this, somewhere around this, and for this here it's back in the back side. Okay. Now students, this radius inside the sphere, it is called radius, but when you bring the mirror outside the sphere, when you bring that spherical mirror outside the sphere, that radius is called radius of curvature. Yes, that radius is called radius of curvature. I'm sure that many of you have heard about it. Curvature. That's called radius of curvature. You must have heard. Radius of curvature of this mirror. Radius of curvature of concave mirror is 5 centimeter. Radius of curvature of convex mirror is 10 centimeter. So what is this radius of curvature basically? This radius of curvature is the radius of the actual sphere from where it is derived from. It is the radius of the actual sphere where this whole mirror has been derived from. Now there are some parts associated with the spherical mirror. So let me talk about those parts which are associated. Now let me take a complete concave mirror. Okay. Now what I'm going to say for concave mirror also applies for convex mirror. So there is no discrimination. I'll show that also. Okay. So first we understood what is a mirror, spherical mirror. Now let's understand the different parts of a spherical mirror. Right. So now let me make a concave mirror, which is going to be a part of a sphere like this. This is a concave mirror. The outer side is non-reflecting and the inner side is reflecting, as you know, and as the definition says. Remember, it's a concave mirror. See, there should not be any confusion between concave and convex. Concave inner reflection, concave outer reflection. It's a concave mirror that I am having now. Now, the first part of the mirror that you should know is the pole of the mirror. The first part of the mirror that you should know is called the pole of the mirror. Now you might ask me, where is the pole? Let me tell you how the pole looks like. See, the spherical mirror, see, when a sphere is there and the part of the sphere is cut. If you look like this part of the sphere is nothing but a circle. The two-dimensional view of the sphere is a circle. That circle will have a center, right? So that particular hemisphere, I would say not hemisphere, half of a hemisphere or whatever, has a circle has a center, a geometrical center. So that geometrical center of that particular spherical mirror is called pole. The geometrical center is called the pole. So this is a curved surface, right? Taken out of the mirror. You turn it like this. It looks like a sphere in 2 dimension, but of course it is a hemisphere type of shape. And the geometrical center, I would not say geometrical center exactly. Geometrical center will be on air. It's like the center on the surface of the mirror. That particular point is called as the pole, right? So every mirror, even the convex mirror has a pole. You see, like if it is in the opposite direction, also it has a pole at the geometrical center on the mirror. Okay, so it has a pole. So that particular point is known as the pole, which would be kind of an exact center here. I'll draw it. From there, from pole, from that geometrical center, you extend a straight line. And that straight line has a name, and that's called principal axis. It's called principal axis. You have pole and you have principal axis. Okay, it is an imaginary line. Basically it is a imaginary line, or it has a name. It is basically normal on the pole. Right, every reflection has a normal. Incident, this you must have studied in 8th grade. And incident ray, reflected ray, and the normal. So this principal axis is basically like a normal on the pole. So it is going through the pole and it is like a normal on the pole. It's a normal on the pole. Right, now from here, what am I going to do? Now there are some different parts which I am going to have on the principal axis. The first part, which is already discovered, that's the radius of curvature. Okay, that's the radius of curvature. Now if this whole thing was a circle, it would have a center, right? You see, let me imagine this is a norm. This is a, if this particular line, if it is the, if this particular line is the principal axis, just let's imagine this point is the center of the sphere, right? Center of the sphere. That is what the same thing I have. This is the center of the sphere. Okay, this will be the center of this particular sphere, which from where this part of the mirror has been taken, right? And the distance between the pole, now comes the distances. Okay, now you have, this is called center of curvature. This point, this is called center of curvature. So basically the center of the whole sphere is called the center of curvature for the spherical mirror. Now the distance between the center of curvature and the pole is called radius of curvature. The distance. Now radius of curvature is a distance. Center of curvature is a point. Okay. The distance. Okay. The distance between C and P. This is C. Okay. Radius of curvature. The point radius of curvature is given by C, which is the center of the sphere. And P is the pole, of course, which I told you about. Pole, I discussed already about what is pole. Right? Now, right. The distance between the center of curvature and the pole is called as the radius of curvature. Now, there is one more special point that comes in a spherical mirror. Okay, there is one more special point that comes in a spherical mirror. And that special point is focus. It's called focus. Now, how focus was discovered or how focus was made? It's by sending a parallel beam of light on the spherical mirror. So you see, it is said that when parallel beam of light falls on the mirror, okay, parallel beam, remember it should be parallel, it passes through a certain point on the principal axis. It passes through a certain point on the principal axis. On where? On principal axis, not anywhere outside that. It passes through a certain point on the principal axis, and that point is known as focus, represented by F. Okay, represented by capital F, and that point is called focus. Focus, focus. Okay, and the distance between focus and the pole, so all the distances are taken from the pole. So the distance between focus and the pole is called focal length. Of course, it's called focal length, isn't it? So I have my distances. I have my radius of curvature, I have my focal length, I have my center of curvature, I have my focal point, I have my principal axis, and I have my pole. So these are some of the important distances and important points related to a spherical mirror. Now you might ask me, don't we have this for a convex mirror? Yes, we have this for a convex mirror also. Right? We have this for a convex mirror. And there is a small difference that I'm going to make. Okay, for a convex mirror, it's like this. Now you see here, I have a convex mirror which is facing outside. The reflecting part is basically outside, and this is the non-reflecting part. My non-reflecting part is this. And a very important rule, draw the principal axis. Principal axis now becomes like a base for your image formation. Without principal axis, you are not going to do any image formation. Either it be 10th standard or either it be 12th standard, doesn't matter. Without principal axis, your image formation can never happen. So now you have principal axis, which is passing through center of curvature, focus, and pole. So principal axis is the only line which passes through center of curvature, which passes through focus, which passes through pole, isn't it? So how does that now, add up? It adds up like this. I have my pole here, but where's my center of curvature? My center of curvature should be in the backside, right? Because the sphere is in the backside, so center of curvature is in the backside. And the distance between pole and the center of curvature is radius of curvature as usual. There is no difference. There is no difference, only the side changes. Radius of curvature. And now you might say that where is my focus here? Okay, I'll tell you where the focus comes. So I told you, in order to find the focus, you always have to send parallel beam of light towards the mirror. So I'm sending the parallel beam towards the reflecting side in this direction. Okay. Now you should know that a convex mirror is a diverging mirror. It diverges the light, whereas a concave mirror that you are seeing here, the concave mirror is a converging mirror. It converges the light to the focus. It converges the light to the focus. If I draw, and it's very much important for me to draw the direction of ray. This is very important, students. When you draw the ray diagram, make sure that you show the direction of the ray. If you do not show the direction of the ray, then you will end up losing mark in CBSE. It's very important. Same way, if I show the direction for this side, it's diverging. You look here, it is converging in this case. It is converging in this case, but in this case, it's going to be the diverging. Light is going to diverge away from one point. Light is going to diverge away from one point. And what that point would be? So it should be like this. It's going to diverge away. So this dotted line is just, for representation purpose. The light does not go like this. The dotted line is just representation, and light is diverging away. Actual light is diverging away like this. But diverging away from where? Diverging away from a point which is known as focus. So in this case, the rays do not converge towards the focus. They do not even go towards the focus. They don't even go to the focus. But they diverge away from focus. So here also focus plays an important role when it comes to the light when it is sent. Right? So this is one thing that is talking about. So here also I have the focal point, and I can have my focal length. Okay, and this distance is called focal length, just like this same previous one. Focal length. Right? Now these are some of the important, parts related to the spherical mirror. Now there is one relationship which I want to tell you, and that relationship is, there is no derivation based on that. Right now you don't have derivation in 10th grade, but you will have derivation later when you go to 12th standard, and that derivation is the focal length f, small f. Focal length is usually given by small f. Focal length is half of the radius of curvature for any mirror, either convex mirror or a concave mirror. Convex mirror or a concave mirror. So that is something which is very important. Okay, now with this you have understood the two types of spherical mirror and the parts which are associated with the spherical mirror. It's very much important for you to know. So if you know these basics, and they are going to help you to understand, or it will help you to do even complex problems. So that is very much important for you to understand. So this was about the introduction to the spherical mirror. I would like to take a session on the ray formation, the rules of ray formation, sign convention on optics. But I want to give you the opportunity to select what I should take. And that's the reason why in this description you will find a poll kind of stuff where you all can do a polling, and I will see for the next week which class or which particular session I should take for 10th grade students. Okay, so if you want me to take class on some particular topic which is given in that particular polling, all are from optics. So if you wish to do that, please do poll, please to give your opinion so that it will help me to understand what my students want to see, and I would like to make the video on based on that particular topic. So students, with that I will end today's session. I hope you have understood today's concept. It's very simple concept, students. I took this 25 minutes just for that particular, for you to understand what spherical mirror. Once you understand the spherical mirror, then only the complex parts of spherical mirror, the complex problems on spherical mirror you will be able to do. There is a lot of things. There is sign convention, there is ray diagram, there is many problem solving. So please do cast your vote. Okay, you can do this voting at least. So please do cast your vote and tell me what should I take in optics for you in the next session for 10th grade. So I hope you understood my instructions. So with that I will end today's session for 10th. I will come with the videos for other classes. So until then, adios.